We are moving away from factoring, which we spent a week doing, and we're going to switch into other ways to work with quadratics, other ways to simplify, and other ways to solve them. So today's lesson is focusing on square roots. How do we simplify square roots, and how do we solve square roots? So first, I want to make sure when you hear the word simplifying, you understand what it's saying. Simplifying does not mean grab a calculator and get a decimal. In fact, you will not have any decimals show up at all today. Simplifying means that you are looking for the largest perfect square factor that will go into the radicand. Radicand is just a fancy way for saying what's under the radical, so that you can rewrite it by simplifying the part that is perfect. So to give you an example of what I mean, let's say you were asked to take the square root of 200 and not grab a calculator. What you're going to do is you're going to figure out what perfect square number is a factor of 200. 200 is not a perfect square on its own, but if you think about your perfect squares are numbers that are a number times itself. So like 25 is a perfect square because it's 5 times 5. 49 is a perfect square because it's 7 times 7. So your perfect square factor, I do a lot of breaking down into factor trees in this lesson. The perfect square factor, the biggest one that goes into 200 is 100. So you make a factor tree and figure out what is the largest perfect square factor that goes into 200. It is 100. And then you're going to take the square root of the perfect one. I always write the perfect one first so I can see that. So the square root of 100 is 10. And then the part that was not perfect, the square root of 2, is left in your answer. This is called a simplified radical, meaning you did as much as you could with it. You did not grab a calculator and find a decimal, and you're going to leave it in this form. So in order to be successful with this, it's really important that you know your perfect squares. You should know this list. This might be a list that you just want to put on the top of your notebook paper and go through so that you can use it as a reference list. I don't usually go beyond 12 squared equals 144. I try to stick to the first 12. I feel like those are the ones students are most comfortable with. So when you're looking at simplifying radicals, you are going to want to look at this list of perfect squares to help you figure out the greatest perfect square factor. Obviously, I went really high. I went up to 20 squared, but I think 1 through 12 is perfect. So you're going to be given basic ones, you're going to be given multiplying ones, you're going to be given dividing ones. We're going to go through and do like the basics and the multiplying in this video. So you're going to look at your square root. Obviously, first check and see if it is a perfect square. If that's the case, you take the square root and you're done. If it's not, you want to do a factor tree and you want to break it down into the largest perfect square factor that goes into it. So the largest perfect square factor that goes into 20 is 4. I usually write that number first. You're going to take the square root of the perfect one. The square root of 4 is 2. And then you're going to leave the not perfect square, the 5, left under the radical. Essentially, if it's perfect, it comes out. And if it's not perfect, it's stuck under the radical. Same thing with 12. That is not a perfect square, but 4 is a perfect square that goes into 12. So you're going to take the square root of 4, which is 2, and then the square root of 3, which is left in your answer. 128 actually has a lot of perfect square factors. When you do this, when you're checking your list, the best thing I can give for advice is start with the higher number. So your highest numbers and kind of work your way down rather than start with the low perfect squares and work your way up. So the biggest perfect square factor that goes into 128 is 64. It is 64 times 2. You're going to take the square root of the 64, which is 8, and then the square root of 2 is left in your answer. If you're really comfortable with your facts and your perfect squares, you may go through these really fast. If you need to kind of grab a calculator to check your perfect squares, it may take you a little longer. 243, what goes into 243? I believe that is divisible by 49. You can grab a calculator to check. Nope, it is not divisible by 49. I'm going to try something else. I'm going to see if I can divide it by 81. That works. Again, it may take some trial and error. And having a calculator to check your arithmetic is nice. Again, we're not going to use the calculator for the actual square root process. So it is 81 times 3. So we're going to take the square root of 81, which is 9, and then root 3. 343, again, you can start dividing. 343 is divisible by 49, so that is the greatest perfect square factor. It is 49 times 7. Again, having a calculator to check the arithmetic helps. Square root of 49 is 7, and then you still have the root 7. 72 also has a lot of perfect square factors. 4 goes into it, 16 goes into it, but the biggest one is actually 36. It is 36 times 2. Square root of 36 is 6, and then we leave the root 2. Moving now into what do I do if I multiply? What do I do if there's a coefficient in front? So kind of showing you some variations. Same overall strategy is going to happen here. So with square roots, we are allowed to multiply values that are under the square root as long as they're both under a square root. So we can multiply the 6 and the 15 together first. 6 times 15 is 90. And then keep the square root around that entire product. So that is one of our legal maneuvers with square roots. Now I can break it down because 90 is not a perfect square, but a perfect square that goes into 90 is 9. So you can break it down into 9 times 10. Square root of 9 is 3, and the 10 will remain. So that's how you multiply square roots. You're going to actually multiply their radicands or what's underneath together first and then simplify. If there's a number in front of the square root, you're going to kind of leave it there to start, and you're going to start by breaking down what is under the square root. 45 is not a perfect square, but 9 is, so we can break it down into 9 times 5. So we get the square root of 9, which is 3, and then the square root of 5. So now I have this negative 3 that's going to come down. That negative 3 can be multiplied by the 3 that's now in front of the radicals. A good rule to think of is if it's under the radical, if both things are under radicals, they can be multiplied. If both things are outside of radicals, they can be multiplied. If one's inside and one's outside, they don't get to intermingle. So negative 3 times 3 is negative 9. And then we're going to leave the square root of 5 as part of your answer. Same thing with this next one. 300 can be broken down into 100 times 3 because 100 is the biggest perfect square that goes into 300. Take the square root of 100, which is 10, square root of 3. And then we're going to multiply this 6 that was kind of just hanging out, waiting out front. So you're going to multiply 6 times 10 to give you a simplified answer of 60 root 3. And that actually is the end of this topic. So this is all multiplying and simplifying radicals using the perfect square list.